Okay, so pressure calculations. So first off, you have your formula right here. Pressure equals force divided by area. So pressure is a force per unit area. For any of these problems, basically what you want to do is to look at what you know and plug it into the equation, then solve for what you don't know. So if we kind of follow along here, so atmospheric pressure at sea level is about 101 kilopascals. With how much total force does Earth's atmosphere push on an average human being at sea level? Assume that the surface area of an average human is 1.8 meters squared. So your units here are kind of important. You have to have the pressure in pascals, not kilopascals. So to do that, you have to multiply Pascal or kilopascals times 1,000. Right, so you have 101 kPa times, make a little conversion factor here, 1 kPa is 1,000 pascals. So basically you're multiplying it by 1,000, okay? Because kilopascals cancel out. So you end up with 101 kilopascals. So if we kind of do this here, we have pressure equals force over area. Our force at this point, we don't know actually. We don't know our force. We're looking for that. Our pressure is 101,000. 101,000 pascals. And our area is 1.80 meters squared. And then the force we don't know. That's kind of where that is. It's that part of your problem there. And then you're just going to solve for F. So to do that, remember in algebra, you kind of undo things by doing the opposite. So we're dividing by 1.8 on this side, so we're going to multiply by 1.8 square meters. Okay, going to multiply the other side by 1.80 square meters. So that cancels out on the right side. That leaves force. And then on the other side, you take 1.8 times 101,000, you get 182,000. And the units you end up with when you actually multiply it would be meters squared times pascals. But the Pascal is equal to newtons per square meter. So if you multiply that times square meters cancel out. So you're left with 182,000 pascals. So that's how you work these out. And then you just have to decide what you know and what you don't know. So if you look at some of the other problems, these are some of the ones that are in the problem set. Number 8 down here. So a diver who is 10 meters underwater experiences a pressure of 202 kilopascals. If the diver's surface area is 1.5 square meters, with how much total force does the water push on the diver? This then is the same exact problem you just had. Okay. It's the same problem we just had up there. So the thing is, you got to figure out what numbers you're going to need from this. So your pressure, we have right there, 202 kilopascals, which so if you multiply that out, that is going to be 202,000 pascals. Okay. And then the surface area is 1.5. So you just take those numbers and plug those into the same equation you had up here. And then a car weighs, down here number 9, car weighs 15,000 newtons and its tires are inflated to a pressure of 190 kilopascals. How large is the area of the car's tires that are in contact with the road? So here, if we look at our equation, pressure equals force divided by area. Well, we have a pressure here. So that is our pressure. And then we have a force, and we're asked to calculate area. Okay, so just plug those in. You're going to solve for area. In that case, you're going to have to multiply both sides by the area, and then kind of divide both sides by the pressure. So pressure cancels out here, area cancels out here. So you're left with area equals force over pressure. Okay. And then the last one down here, number 10, basically looking at the atmospheric pressure on the surface of Venus, it's 91 times the pressure at sea level on Earth, with approximately how much total force would Venus's atmosphere push on an average human at sea level. We're going to assume again that our surface area is 1.8 square meters. So this is the same exact thing as your sample problem up there, except instead of 101 kilopascals, which is the pressure at sea level, you got to multiply that by 91. So your pressure for number 10 down here is going to be 101 times 91, because it's 91 times the pressure